Hi everyone. We want to find the equation of the tangent line to 9x squared plus 16y squared equals 52 through the point 2 comma negative 1. And the first thing we do is find dy, derivative of y with respect to x. And the best way to do this is implicitly because we have the x's and the y's. So to take the derivative, we're going to say the derivative of y with respect to x equals, basically you're going to take the derivative of that, so 18x, and then this is going to be plus 32y, derivative of y with respect to x equals 0. Now just solve for dy dx because that's what we want. So we have 32y, derivative of y with respect to x equals negative 18x, and divide both sides by 32y, so you get derivative of y with respect to x equals negative 18x divided by 32y. And this simplifies to negative 9x divided by 16y. So that's your derivative. Now we're just going to plug in your x and y to get the slope of the tangent line. So we know that derivative of y with respect to x is negative 9x divided by 16y. And our point is 2 comma negative 1. So just plug that in. So you get negative 9 times 2 divided by 16 times negative 1. And that's going to equal negative 18 divided by negative 16, which equals 9 divided by 8. So that's your slope. And now we're going to use the point slope formula to find the equation of the tangent line. So we have y minus a negative 1, which is going to be plus 1, equals your slope times x minus 2. Now in this case they want the equation in standard form. So we're going to multiply everything through by 8. And if you multiply everything through by 8, you get 8 here. And if you multiply this through, the 8 will go away. So we're going to get 8y plus 8 equals 9x minus 18. Now let's put this in standard form. I'm going to write it again here. We have 8y plus 8 equals 9x minus 18. So I'm going to go ahead and keep the, this is linear, so we're just going to put the x first. So we have 9x, subtract the 8y, so it's minus 8y, and subtract the 8, and so that's going to be minus 26, and this equals 0. And this is how they have the answer on the multiple choice portion of your AB calculus exam. Thank you. Have a nice day. Bye-bye.